classroom.
Only
Hooray.
watching this video to get views and likes.
If any of you come up to the board, it will become unlisted. And then other people won't be able to see it.
I'm already
So, but if I say your name, I don't have to make it unlisted. And I'm going to be editing the first part of this out. Morgan.
Is it cricket or is it crooked?
It's cricket, not cricket.
You're dumb.
Obi-Wan Kenobi is in here.
Okay.
And
Ooh, like book. Crooked. Okay, this portion of English class is over. Let's do math. Okay, so math with numbers and scientific notation is an extremely valuable skill
yay!
if you're going into engineering or science. Okay, I'm gonna be real. In your real life, you're not gonna do it a lot. I have never been baking and randomly needed to do exponents, but
If you go work out at the site.
if you go work out at the site, you're gonna be doing this stuff. If you, I mean, there are places for this. So
If you're a math teacher, you'll be doing this.
if you're a math teacher,
Says Obi-Wan Kenobi in the
if
back.
you're a math teacher, you do math all day long and all night long, and all you do is math, which is great because I enjoy math. So let's pretend I have a planet. We're gonna call it planet Zoltar.
Zoltar, yes.
And Zoltar is this many miles from the sun.
Like 40 billion.
9, 3, 2, 0, 0, 0, 0, 0, 0, 0.
Oh, not miles, meters. Wait,
Sit down correctly.
meters from the sun. It's that many meters from the sun. It's in our solar system. We just discovered it. Oh, hey, Zoltar's been hiding out behind Jupiter for the last little while. We just discovered Zoltar. How long does it take the light to get from the sun to Zoltar? Okay, we need formulas first of all. First of all, what's the speed of light in a vacuum?
1,108.
It is C,
Cube.
not C squared, not C cubed. But what is C? I need
MC 300
300 million.
300 million. 300 with 6 zeros after it.
Thing that is like.
Okay, meters per second. Okay, the formula for distance equals the rate times the time, or speed. We'll call it speed for y'all. Although I like calling it distance equals rate times time because it's the dirt equation.
Dirt.
Dirt. So time is equal to distance divided by speed, okay? Do I have distance?
Yes.
Do I have speed?
Yes.
Can I figure out time?
Yes.
Here's the deal though. There are an actual crap ton of zeros here. Do I want to deal with a crap ton of zeros?
Unless you're using a calculator, heck no.
No, even, okay, so try entering that one into your calculator.
Can you
Do
tell me
it.
how many zeros there are just so I can actually...
1, 2, 3, 4.
The zeros.
There's like 12, 13 zeros.
It won't fill the zeros.
There comes a point in your calculators where Ronan might be able to because his is big enough, but these calculators cannot handle that many zeros. You could do this with a calculator if you tried. So what do? I don't want to deal with that many zeros. What? How do I do, Case?
Well, in a calculator or just.
Real life to get rid of all these zeros.
So you put 9.32 and then count all those zeros. 1432.
Times 10 to the, put it into scientific notation to make it easier to deal with. Ronan.
So, yes, after we count the zeros, we'll use how many zeros it takes from the point of the decimal to the last.
It's 13. Is it 13 zeros? Let's count it together.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
So 9.32 times 10 to the 14th meters, okay? And C is 3 times 10 to the what meters per second?
Wait, 1, 2, 3, 4, 5, 6, 7.
3 times 10 to the 8 meters per second. That is a number that is so tattooed on my brain, like I will never forget that one. All right. So time equals distance times the speed. So time is equal to distance, which is 9.32 times 10 to the 14th meters, divided by 3 times 10 to the 8th meters per second. And our answer is going to be in seconds. So, can I do this?
Yes.
Now remember back in the olden days when life was easy and short. And we would have like 25 t to the 4th divided by 5t squared. What would I do first?
You'd add.
I wouldn't add. What would I do first, Kate?
25 by 5.
Divide, what's 25 divided by 5?
5.
5. What, and then we divide, what's t to the 4th divided by t squared? T to the 2nd, how did you get that number? But I've subtracted 4 minus 2. You guys both got it. When we are dividing numbers in exponential form, we subtract the exponents, and we have t squared. So, following that pattern, what do we do here?
Divide.
Divide. We divide what by what, Morgan?
9.32 divided by 3.
Yes. What's 9.32 divided by 3?
3.106.
Oh, we're gonna call it 3.106, and we're gonna. Okay, we're gonna call it that. Just do my. All right, 3.106. In fact, we're just gonna round it to 3.1 for our simplicity of life. We'll even just do this. Well, no, we'll leave that at 2. All right, so we have 3.1 times. Okay, so I have 10 to the 14th divided by 10 to the 8th.
Just minus 8 from 14.
I just subtract 8 from 14 because why? When I'm dividing numbers in exponential form, what do I do with the exponents, Morgan? You subtract. So we have 10 to the 6th seconds. By the way, 10 to the 6th is a million. So I have 3.1 times 10 to the 6th seconds. So how many seconds, how long does it take for the sunlight to get from the sun to Zoltar?
3.1 times 10 to the 6th seconds.
3.1 million seconds. That is a hot minute right there. That's like a hot minute or 12. Like, that's a long time. Is the light gonna ever get there?
Yes.
Yeah, it's just gonna take 3.1 times 10 to the 6th million. Or 3.1 times 10 to the 6th seconds, which is 3.1 million seconds. It's gonna take a bit, but it'll get there eventually. Zoltar is very, very, very far from the sun, which is probably why we just discovered it like yesterday. We didn't really. This is made up. Please know that. Okay. So,
I'm gonna go home and say, Dad, there's a new planet.
yeah, and don't go home and say, Dad, there is a new planet, because your teacher's full of garbage. I'm just pulling stuff out of my head.
Yes. Pull stuff
Mom, there's
out
a
of your head.
Yeah.
Now you say, Mom, my teacher taught me to figure out the distance to a new planet if I know the speed. All right, let's do another one. Okay. Do we want to do a big one or a little one? Should we do a teeny one?
Yes. An average.
Just have it be.
Okay. Just have it be 0.
Yes.
0. We're just
Have it
gonna
be
have
10.
0.
Does it is the unit for it miles per second squared or meters per second squared?
The unit for time is seconds.
Well, I'm talking about like for the answer.
Have it be
We came up with 3 whatever million seconds.
Okay.
3.1 times 10 to the
Thanks.
6th.
3.1 million seconds already gone from my brain. That's how fast I just move on. When I say circle it and move on with my life, guys, I mean it. Like, it's gone. So, all right, let's say I have, guys, yesterday I lied to you. I said that Avogadro's number was 6.22 and I forgot a 0. It's 6.022 times 10 to the 23rd. Okay.
Woo!
Right? So let's say I know that 1 gram of hydrogen
1 gram of hydrogen
has 6.022 times 10 to the 23rd protons. I know that.
But how many neutrons?
That's a lot of protons.
0. No neutrons unless you have deuterium in there, but hydrogen doesn't generally have a neutron with it. You could have deuterium in there, and you look at the averages, but we're going to pretend that there's no deuterium in our hydrogen today. Yes.
And if it was on a calculator, you do 6.022 E23.
Right. When you enter it into a calculator, you put 6.022 and then E and then 23. But we're not going to use a calculator today. I want to know what is the mass of one proton. How would I figure that out? Morgan, how would I figure that out?
Divide them.
Divide what by what?
The number of protons in 1 gram of hydrogen.
1 gram of hydrogen divided by the number of protons.
6.022 x 10.
Okay. How do I do this?
You have to make
Divide.
the things like.
I have 1 over this number.
You gotta figure out one.
Colby, what do you think?
Wouldn't it be the 6.22
Times 10 to the, if we bring it up into the numerator though, it's crossing this line,
negative?
10 to the negative 23rd grams. So 1 proton, now that was kind of an easy one because it was just dividing by 1. But 1 proton weighs 6.022 times 10 to the negative 23rd grams. So I want you guys to think for a second. Protons weigh the same as neutrons-ish. Neutrons are slightly more massive, but not enough to talk about for our purposes. How much do you weigh?
Skinny.
More than 2 pounds.
More than 2 pounds. Let's pretend we know that each proton weighs this much. I know that I think I weigh about 60 kilograms. So we're gonna do this based on Mrs. Barlow. I weigh about 60 kilograms, which is how many grams? 60 times 1,000, so it's 60,000 grams. Woohoo! Okay, so we're gonna calculate how many protons and neutrons I have in me. Can we do that?
Not easily.
Is it gonna be a big number?
Yes.
It's gonna be like an absolutely enormous number. And actually we can do it quite easily. If 1 new proton weighs this much and I have this much weight, how do I figure out how many protons there are? I would divide. Divide what by what? By 6.022 times 10 to the negative 23rd. Now, I'm going to put this in exponential notation, in scientific notation, so that I can do it a little bit more easily, actually. This is 6 times 10 to the what?
1, 2, 4.
4 or 5?
4.
1, 2, 3, 4. So 6 times 10 to the 4th divided by, for our purposes at the board here, I'm just going to call it 6. I'm going to round it to 6, knowing that it's 6.022, okay? Times 10 to the negative 23. Okay, could we do this?
Yeah.
Is it hard?
Uh-huh.
At this point, actually, I hope it's not. Okay, what's 6 divided by 6?
1.
1 times 10 to the, okay, we have 10 to the 4th divided by 10 to the 23rd. Their numbers in exponential form before I subtract them. So I have 4 minus a negative 23. These become a positive because we have, it's the opposite of subtraction. So what's 4 plus 23? So how many protons and neutrons do I have in my body? About, right? We're not exact here. I'm not even exactly 60 kilograms. About 1 times 10 to the 27th protons and neutrons.
Which is insane.
Which is a mind-boggling number. And that's just me, right? How many are in this room? It's crazy. Crazy to think about. I do want to show you something that might happen and how to deal with it, okay? Let's say I have 3 times 10 to the 14th divided by 6 times 10 to the crossing out numbers. We divide the regular numbers. What's 3 divided by 6?
0.5.
0.5 times 10 to the what?
14 minus 8.
14 minus 8 is what?
6.
6. Is this in proper scientific notation?
No.
No. What do I do? How do I deal with this? Case.
You change the 5 to it above 1 5.
We move it right, and then what happens to this
and then it
exponent?
turns negative.
It doesn't turn negative. I moved it
Oh,
to
yeah.
the right one, so I lose 1 on my exponent times 10 to the 5th. Okay? You're going to run into that. It's going to happen, and you need to fix it. Or if I end up with like 27 times 10 to the 4th, I move it that way, and I get 2.7. I moved it to the left, so it goes up 1 times 10 to the 5th. Okay? How are we feeling? Feeling good? This is just pretty much what, tired? It's okay. Just had lunch and you're digesting. Oh, I had an optics class in college that was right smack after lunch. So I was digesting, and it's optics.